Okay, we are going to discuss the homework problems today. Last time I told you to tell me the other problems. We have discussed their problems, homework problems. So they were asked to do the rest of the problems and show me. And other people need to show all the problems. So who wants to share the screen and quickly explain what he or she has done? Do it fast. Ajita, can you do? Since you are not doing.
Yes, ma'am.
Yeah, share the screen and.
So first problem where the bearing angles are given, we have to find the user coordinates. It is similar to what I have done. I have found the line equation for the transmitter line and this TTR2 line, and I found the intersection points of those. That will
First
be
of all,
the
1 minute, 1 minute.
okay.
See, what is phi? Or, what did you write? Psi.
Psi 1, psi 2.
So the equation, so tan psi is actually x by y. What you are doing? You are doing y by x. That itself is wrong, right?
Ma'am, slope of the line means I found this angle, ma'am. I extended this line
But
and I
what
found.
angle is given? What angle is given? So you have to do some adjustments. You are showing one angle and you are assuming another angle, right?
I found this angle from this psi 1 angle, ma'am.
You found it?
Hmm.
Show me the equation quickly. What equation you wrote? Okay, fine. Fine.
This one.
Then next.
Then I obtain user coordinates xu, yu. Then the
Hmm.
second problem, like I couldn't think of another solution to find out xu, yu. This is the same which I showed you last class only.
Okay, fine. Other problem?
Then third problem, the Doppler effect. This
Hmm.
is what you have given us. This is the relative velocity. Component of relative velocity in this direction is Vr cos theta. Now we have to find the shift in frequency of these waves. So this is the projection, you know. Let the transmitter send a signal cos 2 pi f t. T is the transmitter frequency, and wave travels for time t naught. The time taken by this wave to travel the receiver is say t naught. So the signal received by the receiver would be this amplitude cos 2 pi ft into t minus t naught. Since it is decreasing function, so t minus t naught.
That's fine. Next.
As the transmitter is moving further away from the receiver, signal is delayed further by t1 times. Since both are moving, there is a relative motion. So signal will be further delayed by t1. So final received signal would be this. Arca cos so and so t minus t naught minus t1. So here the t 2 pi f t naught is taken as a constant phase shift because it is the delay time for the wave to travel from transmitter to the receiver. And to find t1, see, t1 is because of the relative velocity between those two. So ct1, the distance travel is equal to relative velocity
T1,
cos.
T1, 1 minute. Go up.
Okay, okay.
What is T naught? Go up. T naught
T
is the
naught is the time taken by the signal to
Okay.
go to the receiver, but T1 is the time taken, a delay time due to the relative velocity between those two. This.
But if the distance is, see, when there is relative motion, distance is changing, right? So you can't say T naught is constant. Basically, it
I'm
is.
not telling T naught is constant, ma'am. I mean it is represented by this. This part is represented by phi naught. Okay, fine.
It
Constant
can be
phase
taken
shift
as the
over time.
initial distance. Okay, fine.
Initial. So then to find the T1, see T1, that is velocity of the wave into T1 is equal to relative velocity, the component of the relative velocity into time T. So I
Fine.
found.
Next,
So then
found
the
time.
final signal equation is this 2 pi into ft. I took t common, so ft minus so and so minus
Oh,
phi naught. So this is the frequency shift which we are observing, known as the Doppler frequency. So I brought fc this side, so minus we are cos at ft by c. This is represented as VA capital in your slides, so ft by c.
just go up.
Mm.
You are substituting for T.
T minus t naught minus
No,
t1.
no,
T
no,
naught.
not that one.
Okay, fine.
Scroll down.
Mm.
So you are writing CT1, okay, fine, and you found T1, and then you are substituting for the T1.
Back in that equation T1.
But this will give you the shift, phase shift. It is not frequency shift. Yeah, okay, then
But 2 pi f into t, right? So here we are considering the frequency from the term.
how are
Uh,
you getting T there? You have already substituted for T1, right? You don't have T, so you are
see,
substituting for
it is
T1,
like
correct?
cos omega t minus 5, ma'am.
But
Like,
you do not have T then. If you are substituting for T, oh, you have T there.
yeah,
Okay,
sub
fine, fine,
t
fine, fine.
is
Then,
there, ma'am.
yeah,
I,
yeah, okay, then scroll down, scroll down.
then
Let's
finally, that is
found
the,
it in terms of T.
yeah, I mean, from
But
the,
how can you do that? Just go up. C U dot C T1 is equal to
the
CT.
line of sight, I mean, along that line of sight, relative velocity in time would give the distance traveled, right?
But
This is
why
given
two
the,
times are different? This is the extra distance traveled.
this is the time traveled by the wave. This is the, I mean, distance traveled by that wave. This is the distance traveled by those two bodies. I mean, in that t1 delay time.
But the T is what time? From when to when? That is not clear. The T time, you know, that is which time? From when it started? That is important. You are close. Next problem.
Fine. The fourth problem I did not get, ma'am. I tried to imagine, but I didn't
Okay,
get
next.
t equal to r. And the
Next.
fifth problem, for x and y coordinates, I have taken the projection of re plus h on this plane. So cos re plus h cos l cos lambda would give
No,
coordinate
no,
in
you
x
just show me the steps and the diagram and the.
diagram and x and y
The
coordinates. The
next,
z
next,
z
I want to
coordinate,
see Z.
I did not get that, ma'am. Like I tried
Next,
for some.
if you did not get, you need not explain. You did not get. That's it. Next.
Okay, fine. That's it, ma'am. I did this. I mean, I tried these tutorial problems again, ma'am.
Okay, next. Who will explain next?
Yes, ma'am. I'm Krishna.
Yes.
Okay, ma'am.
Do it
Yes,
fast.
yes, ma'am. This is your first question.
I
Uh,
cannot see. Yes, enlarge it.
is it visible, ma'am?
Yeah, it is better. Next.
Yes, ma'am. X1, Y1 is the coordinate of transmitter 1, and X2, Y2 is
That I know. That I know. Just tell me the
if
key
if
steps.
if anyhow we will get D, the distance between user and transmitter 1,
D is
then
not required. I told you that you require only bearing only. Anyway, first, show me what you have done.
then I obtain D using there are many angles like gamma, delta, theta, alpha, beta. So
Then
D is there, and then X is X1 plus D sin alpha, and Y is equal to Y1 plus D cos alpha. This is the coordinate of X user.
now what is delta x? You do not know delta x.
No, ma'am. Delta X is known. This is X2 minus X1.
You do not. Delta x is x2 minus x1.
This is transmitter 1 coordinate and transmitter 2 coordinate. This is the difference.
How about that beta, alpha and beta angles? Beta is not known then. You, how can you relate D using only two transmitter coordinates without the user? That itself is not clear to me.
Ma'am, beta is there,
D,
alpha is
D is
also
the
given.
D, beta is there. D, D is the distance between the user
Ma'am,
and the transmitter, right?
in the question it was written that, it was there that coordinates are known. Location of
Transmitter
transmitter are known.
coordinates are known.
Yes, ma'am. And alpha beta are also known.
Alpha and beta are known. Yes.
Yeah. Then this beta is with respect to y
So
axis.
delta x cos beta. What
Yes,
is
ma'am.
delta x cos beta? What is
Delta x is
beta?
the
I know
ma'am,
delta x. Delta x cos beta is which
ma'am, beta
distance?
is the angle between y axis and that line of
I
sight
know
between.
that, but tell me what is delta x cos beta? Which length is delta x cos beta? Show me.
Ma'am, actually, I applied a sine rule here, d by sine delta, and this distance divided by sine
Where
theta
is
again.
that step? That step is not there. I told you to write down all the intermediate steps. Why are you
Ma'am,
writing the final answer? This way you will not get
no, ma'am,
marks.
ma'am, this is not final answer. Actually, theta is, uh, I applied parallel, if two lines are
Now,
parallel,
where are
and
those steps? Those steps should be written down. Why are you
Ma'am, actually,
explaining in words? No, there is no excuse. You got enough time. You need to write
ma'am,
down intermediate steps. How you
ma'am,
got D.
that was too lengthy, and this triangle is there,
Lengthy,
ma'am.
then also you should write down. What do you mean by too lengthy? You got time. It's not that you have been asked to do it in 5 minutes.
Ma'am, can I
If you write in
upload
the
this after?
exam that it is no, it is too lengthy, how will I give you marks? I cannot give you
Ma'am,
marks. So you need to
ma'am,
write down the intermediate steps.
ma'am, please give me time. I will upload after this class.
Okay, next.
Then this is the
And you
second
are
question.
making it unnecessarily complex. That's all I want to say.
Okay.
Tan rule you could have used, right? Tan theta you could have used easily for the first
Yes,
problem.
ma'am.
In the second problem you are doing tan. In the first problem also you can do tan. Then D is not required.
Ma'am,
Next.
previous class I did that, but I
Okay,
did some mistake.
whatever you have done, you show me the steps. Okay, you send me the email showing
Okay,
all
ma'am.
the steps.
Ma'am,
Uh,
actually,
show
this
me,
is
show me
Dr.
the
Step.
previous one.
Okay,
You
ma'am.
wrote something, tan theta, something. I want to see.
Ma'am,
Then
actually, all
after that,
angles,
you didn't do anything.
ma'am, x, y, and z, x, y. There are three equations and two unknowns, so we can solve this.
Why two unknowns? Theta is not known. How can you
Sorry,
say theta?
sorry, ma'am. Yes, ma'am.
So
That
how will you solve with those steps? Also, you have to show. Simply, if you say you
then,
three equations, three unknowns, you will
ma'am,
solve
this will
and
be a non-linear equation, ma'am. That I have to.
show the steps and tell me how you will solve.
Okay,
Next,
ma'am. I think the third one is wrong again.
why
Actually,
you have done
I
and then
copied from Wikipedia, and this is F is the received
copied from
frequency.
Wikipedia. Why did you copy from Wikipedia without understanding?
Actually, I was trying to obtain from many papers, but I was not getting this. But
Do not do this without understanding anything. Do not copy things.
okay,
Next, anything else you want to discuss?
yes, ma'am. For question number
Yes.
four.
Hmm.
So actually, this is CD is equal to RE. So that, ma'am, this picture will be clear if we, uh,
Next, you show me the next thing
ma'am,
that you
I
do.
equate two slopes, and this I calculate x and z axis coordinate, and then
Hmm.
CD is equal to a divided by root under one minus this formula. So this was the formula of RE. So CD is equal to RE.
See,
This is the
show
one.
me once again. This you are showing that CD is equal to RE. X and Z are this. X is
Ma'am,
equal to CD
actually,
cross L.
ma'am, here logic is if we fix the latitude angle
Hmm.
of that any point, then we can rotate that point C anywhere. So that whole picture will be converted into 2D, like x coordinate, and
Rotate the point anywhere, then L will
so,
change. About which
yes,
point you are rotating?
ma'am, I
You
am
do.
fixing
If you
L.
change C, you are fixing L, and then
Yes,
which
ma'am.
point you are changing?
So I am going actually on the prime meridian. So that will picture will be converted into ZX plane only. So I am ignoring y axis.
That is fine. That is the north down section. Then
Yes, ma'am.
in which direction are you changing C so that L is constant?
Ma'am,
You scroll
ma'am, I
down.
think
Scroll down.
it's direction actually.
Each direction, if you change L will be constant. Okay, then
RE will be constant. That CD length will be constant, and L will also be also constant.
L is constant. Then next.
So, ma'am, I am going to prime meridian where that RE will be again same and angle L will be same. So using this equation, that slope is
Scroll
digit
down.
by,
Scroll down. Scroll down.
and again slope will be minus cot L, that slope of that point. So I'm equating this. So I'm getting equation number first equation, sorry, second equation. So equation number three is there, and
You send
one.
me this part, okay? This part I am actually not getting properly, so you send me this part. I'll look at it, and then I'll see. Okay, next.
So, ma'am, this will also give us the coordinate of Z. So, fifth number is there.
Hmm.
So, same what Ajita explained. X is
X and Y I understand. Z.
yes, ma'am. So, for getting Z, I'm going to previous picture. So, same. Actually in previous question number four, Z dash was there. So, extra H is coming here. So, Z is ED plus H sin L. So I'm getting this result.
What is ED?
So, ma'am, ED is I don't know the name, ma'am, but this CD is the
Okay,
RE.
ED. And then how did you find ED?
Ma'am, I have ZS in previous.
But you don't have Z. Oh, previous
Yes, ma'am. In the previous.
problem. Okay,
Yes,
then you
ma'am.
send me both.
Yes,
So
ma'am.
whatever I've asked you to do, you do that and then send me over email. Then next.
This is question number 6.
And you should do that immediately after the class, okay?
Yes, ma'am. So actually, I'm rotating. We are going from ECF to NED frame. So I'm rotating Z axis through lambda angle, and then the
No, this will not give you. In the northern hemisphere, you cannot do it. You require a pitch which is greater than 90 degrees. It's not correct. Next.
and this is 7th number. So which is we have to prove that eigenvalue is 1.
Okay, this you can explain tomorrow. Okay, I'll go
Okay,
to
ma'am.
the next person.
Okay, thank you, ma'am.
Who will explain next? Quickly. Sujit?
Ma'am, I can explain.
Nila, okay.
Ma'am, is my screen visible?
Yes.
Okay. So in question 1.
Okay, I understand. Next.
Okay. Second, I took theta and I subtracted the slope. I have subtracted theta from the phi angle, so I can get the slope.
Subtract theta.
So because
Okay,
this
next.
uh,
That only. You didn't do
uh,
anything else. You just wrote
no,
the equations.
this one second.
Yes.
Ma'am,
This is not sufficient.
ma'am, you can expand M1. If I expand it, it will give the final same
No,
answer.
no. It's not that easy. You expand means
No, just have to substitute M
you have
value.
not written the intermediate steps. You have to write down the intermediate steps. This way, if you write in the exam, you will get 0 marks. That's it. That only I can say. So many people have explained. I am not going to tell the things again for this one. I'll show you the final thing. Okay, next.
Okay, ma'am. For Doppler positioning, we have the user and
So VR is, I understand. After that, what did you
yes.
do?
After that,
Wavelength
I
n is
said
equal to r by lambda. Then
yes. If the distance is r, then the number of wavelengths is r by lambda t. Now we know that lambda in one lambda corresponds to an angular in radians it will be
2 pi.
2 pi.
Hmm.
So number of for r distance it will be 2 pi r by lambda. Uh, Now we know that angular frequency is written can also be written as d phi by dt. So we can
Next. But how
uh,
are you relating it to r? Okay, so
yes.
you are
So we
saying
can substitute it.
phi is the number of cycles. No, the total phase
Yes. The
over
wavelength, the
distance
number of
r.
cycles. Yes.
Okay,
So
and
f
then
is the frequency. So if I so I can write f. I can take 2 pi on this side. So I can write f is equal to 1 upon 2 pi d phi by dt. Now phi we have written here.
but there is a
So
negative sign. How will you get the negative sign? If you especially if you write in terms of r dot, the negative has to be put. So there is something wrong here.
okay, ma'am, I
You
didn't
are
get the
not
negative
getting
sign.
the negative. Yes, you have to get the negative. Probably what you are doing is not wrong, but somewhere some explanation needs to be incorporated. And next,
Okay. Ma'am, the fourth one I did not get how to relate.
next,
Okay, the
next,
fifth one, um, if we take the ellipse, the
next. Yes.
uh,
So where did
ma'am,
you do the steps for Z? I don't see
ma'am, I
that.
did not
Next,
understand it.
you did
Ma'am,
not
this is all.
understand means you had to find Z in terms of latitude, longitude, and height.
Yes, as in I tried, but I did not know how to do it. I couldn't visualize this Z part.
Next, next.
Ma'am, that's all I've done.
Okay, fine. Who will explain next? Apur?
Ma'am, last time what I did not get any extra thing from that.
How about other problems? Haven't you tried other problems?
I did all 5 last time, but some were wrong, so I didn't get it.
And some more problems were also given, right? You didn't try them.
Not yet, ma'am. The angles, Euler angles, I did not do yet.
Yeah, but tomorrow we are going to discuss those things. So if you have not done them, I'm telling all of you, you should do that. Shujit?
Yes, ma'am.
Yes, ma'am.
Yes, do it fast.
It is visual, ma'am.
Yes. Okay, next.
The first problem.
I understood. Next.
Next,
You should write down properly. This is not how you should submit answers. This is not how you should show homework problems.
that is
As if
for
you are
rough
doing some rough work.
Yeah, first
Yeah,
I'm
then you have to
going
you have to write it again. If you are doing this way, you have to write
Yeah, ma'am.
again. This is not how you should show the homework problem solution. In the exam also, you have to write properly.
Yeah, ma'am.
It's
First
very
time
difficult to follow what you are doing.
First time I did not. That's why I'm taking the rough, and then after that I will do the in fear. The first
No, you should
one
not show me any rough work, okay? I didn't ask you to show me rough work. Showing intermediate steps doesn't mean you have to show all these things. You have to write down properly and show me. I do not want to see this way next time.
Yeah, ma'am.
Okay, fine. Next problem.
The second one is the if reference is not given.
So show me. I do not know. I need to know the problem. Show me what you've done.
First one, second one.
Second one I said. Yes, theta is not known. Then after
Theta
that.
is not known. Then I am taking this.
Show me. You do not have to explain from the beginning. I know the problem. Everybody knows the problem. So scroll down. Keep scrolling down.
Okay. From we have got 3 equations and then 3 unknown. Then we can equate from these 3 equations x, y, and theta.
Next.
Doppler problems.
No, you have not solved. You have to find the solution. At least you need to bring the equations to some form where you can easily visualize how the solutions could be obtained. Okay. This is not done completely. If you do it this way in the exam, you will not get full marks. That's it. Simply, if you leave it at this point, then the answer is not complete. Next.
Next one is for Doppler frequency derivation.
Show me.
See, VR is nothing but Vt minus this one, and Vt minus Va means user velocity.
How are you getting Fa is equal to Ft into 1 minus Vr by C? You need to prove that.
This one, ma'am.
Yes.
Okay, Fa is equal to Ft.
So you are just assuming something and you are showing Doppler. This way you will not get marks. If you do this in the exam, you have to prove that. Fa is equal to Ft into 1 minus Vr by C, that has to be proved. Then only answer is complete. How can you pick some relation from somewhere and then just simply subtract the transmitted frequency from the received frequency and show that this is Doppler? This is how you should solve problems. Next, you will not get any marks if you do this in the exam. That only I can tell you. Next.
See that Doppler only, but if
Doppler, there was no other problem. There was no other problem. That was already discussed in the class. SOP was already discussed in the class. Surface opposition was already discussed. What you are showing? Next.
Okay. Next, CD no. I think next to next and after that the fourth one. In fifth one we have to convert x, y, z.
Yeah, I cannot see it properly. It's too hazy to understand anything.
Ma'am, from C to D, that is the RE, and from C to up to this point.
I think you and Krishna did the same thing. Yes or no?
I don't know, ma'am, what Krishna.
Which one you are trying to show here? Which one? Z, that x, y, z is equal
Fifth
to...
one, yeah, XYZ into L lambda and H, and L lambda H into XYZ.
No, it is not visible.
And I have got Z
You
from
show
this.
me the steps for z. I do not want to see x and
Yeah,
y.
this.
It is not written in a methodical way. Okay, this way nobody can follow what you are doing. Which line should be read after which is not clear, and you are just showing me some final answer. Cos L, sin L, tan L.
Yeah, from X and Y we can get from this one, and from that and
No,
Z.
I do not understand. This way I will not try to understand also. Write down properly, then only I will see. And do this one and show me. You should proceed in this, I mean, whatever approach you have taken, that only I want to see. But write it down properly and then send me. And send me right after class. Okay?
Okay.
Next time I do not want to see things this way. You should write down properly and then show me. Next.
And next time CD is equality, we have to justify it.
It is hardly visible. I told you to send me your homework problem answers before class. Why didn't you do that? You should write down all the steps properly and email me right after class for these two problems. RD and then whatever approach you have taken for Z. I want to see that specifically. Then
Okay.
velocity.
Yeah.
What did you do for velocity?
The first
It's
one is
hardly
latitude.
visible. Yes. Latitude.
L dot is about is to down.
Nobody can understand what you have done. Nobody. This way nobody will understand what you have done. And this is not how you should show. I'm telling everyone, you should write down the steps clearly and show me. This is not some rough work, okay? Just because I've asked you to explain the homework problems doesn't mean you will do some rough work and show me. You send this also. Whatever explanation you have written, write down properly and send me.
Yes,
write down the steps methodically one after another in a systematic manner. Okay, next.
Yes. This one is last velocity problem.
Okay, fine. That's it. You can stop sharing your screen because I want to share and explain some of the problems.
Ma'am, so we have to send the tutorial problems to you before the class
No,
starts?
not you. Okay.
Okay.
Only some of them who have network issues, they have. If I do not ask you specifically, you don't need. Okay.
Okay, ma'am.
Only if your steps are not clear, you are not explaining things properly, I'll ask you. Don't think that way you will get extra marks. If I ask you to send me your answers over email, you will get extra marks. Don't think that way. Okay, I am not able to understand properly and that's why I am asking those people to send. That doesn't mean that they will get extra marks. In fact, if you explain properly, nicely in the class, that is better. Here I am showing you sample answers so that you understand how you are going to, how you are expected to show me the steps next time. Okay, so what I want to do is I want to explain first how to get x, y and z coordinates from latitude, longitude and height. So here we see the knot down section of the ellipsoid. This is the point whose x, y, z coordinates are required. This is the height of the body. Okay, and this line CD is actually RE. We know that this angle is L and this is phi, which is the geocentric latitude. This is geodetic latitude and this is the geocentric latitude. Then we are seeing the same thing in 3D. So this one is the, no, you are not able to, you can see my cursor movement, right? Can you see my cursor movement on the screen?
Yes, ma'am.
Yes, ma'am.
Okay, so this is the equatorial plane, okay, and this is the point. So we are seeing it in kind of 3D. So this angle is L and this is lambda, and these are the x, y, and z axis. Is here x, y, and z axis. So if we draw projection of this point on the equatorial plane, expanded equatorial plane, it's not needed that it will be on the equatorial plane. It will be outside because it is outside the Earth. So it will be on the expanded equatorial plane. This point. And this length is actually z, right? Now we can see the same thing on the equatorial plane. So this plane, equatorial plane, now we are seeing from top. So this is the projection of the point. This length is beta, and here also we can see beta, right? And this angle is lambda. So from this figure we can easily say that from this figure we can easily say that beta is equal to RE plus H cos L. This length is beta, right? This angle is again L. So we have RE plus H cos L. And then from figure 3 we can say X is equal to beta cos lambda. So this is X, beta cos lambda. So substituting for beta we get this RE plus H cos L cos lambda, and then Y is equal to RE plus H cos L sin lambda. Next Z. So Z is basically this distance. Now we can divide it into two parts. One is CE. This dashed line here is CE, which is equal to this length. So it is CE, and the second part is H sin L. This is also L. These two lines are parallel, so this angle is also L. So this length is H sin L. So Z is equal to CE plus H sin L, right? Now what we need to do is we need to find CE. What is CE? CE is basically this distance, right? And we can, and this is OE. So we can write that CE is equal to OE into tan phi. This is phi. And then we apply, so CE is, OE is also equal to DF. Just take this rectangle. So OE is also equal to DF. What is DF? So if you consider this triangle, CDF triangle, then DF you can write as RE cos L, right? So RE cos L, and then substitute for tan phi. We already noted the relationship between phi and L. So tan phi we can write as tan L times 1 minus E square, and then plus H sin L. So cos L tan L means we have sin L and then RE into 1 minus E square. So this is the final formula. Is this clear to everyone? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay, next I'll explain the velocity terms. You were supposed to do this. I told you first to work on this also, but you didn't. Most of you didn't. Some of you tried, but the steps are not clear. See, I'm expecting you to write down the steps this way in a clear manner and explain to me. So we need to explain this. L dot is equal to this one, naught component of the velocity divided by Rn plus h. Lambda dot is given this and by this, and h dot is equal to minus VEV, the down component. H dot is very easy because we know that down axis is opposite to height. So height is calculated in this direction and down axis goes in the opposite direction towards the center. Radially inward. So we can, from that we can clearly say that h dot will be the negative of the down component of the velocity. This is the not down section of the ellipsoid. So this is not and this is down. We know that CD is RE, this angle is L, and what is the direction of lambda dot? Lambda dot must be about the Earth rotation axis, about the ECFZ axis. So this is the direction of lambda dot. Now we need to just apply this formula here. We know this is how the linear velocity is related to the angular velocity. V is equal to omega cross r. So we have a circle here, and the point is moving around the circle. R is the radius of the circle. So if you apply that right hand thumb rule, this is Z, X and Y. You just apply the orient the fingers of your right hand thumb along X, then forefinger along Y and middle finger along Z. You will find that this is the direction of V, and then omega is shown, R is radially outward. So we are basically going to apply this formula in this context by suitably finding omega and r. Okay, let's first do this for the L dot term. So this is L. L dot means time derivative of L, correct? So L is actually changing in this direction. So what is the direction of L dot? L dot is perpendicular to the page and away from the page. So you just curl the fingers in the direction of L dot. So when L is increasing, it will move in this direction, right? So the direction of curl should be in this direction, and then thumb should be pointing out. So the direction of thumb will give L dot. So basically this omega is nothing but L dot here, right? The angular motion associated with L, the rate of change of the angular motion is omega, the angular velocity is omega, so that is nothing but L dot here. Now what is R? So we need to pick the best fitting circle, correct? We know that the radius of the best fitting circle in the north down section is Rn, not Re, Rn. And the point is at some height from the surface, right? So we have to add h, that height. So R is basically Rn plus h. Then just apply this V is equal to omega r if you consider only the magnitude. V is equal to omega r. So V is nothing but the north component, correct? When the point moves in the north-south direction, then only L changes, right? So you have to pick the associated linear velocity, right? So the associated linear velocity is the north-south component of the velocity, which is this one. So we know that from this equation, we know that omega is equal to V by R. So we have identified V, we have identified R. So dividing V by R, we get L dot. So L dot is equal to this one, right? Okay, next we need to find this one, lambda dot. Now see, this is the direction of lambda dot. It's about the ECFZ axis, correct? So at this point, let's consider the east-west circle, which has the constant latitude. So L is the latitude, we are considering east-west circle. The linear velocity for that circle is basically this one, the east component of the velocity. And the angular velocity associated with that circle is actually lambda dot, right? Because lambda dot, the direction of lambda dot is perpendicular to that east-west circle, correct? Now, how about the radius of the circle? You see, this distance is Re plus h. So radius will be Re plus h cos L. This distance. So this is L. This angle is L. This angle is L. So we have Re plus h cos L. So that is the radius. So again, using this equation, we can find the lambda dot. Clear? You understood?
Maybe in figure,
Yes, ma'am.
maybe
Yes.
in figure, how can you show the Rn from here to?
That is the base fitting circle we discussed in the class, right?
Okay.
You have to draw the base fitting circle and the radius of that circle is Rn.
Okay.
Next, we are going to find x and y coordinates given bearing measurements. First one is simple, the reference is known, so it is taken as parallel to y. And then using the bearing measurements, we can write down the equations. Tan theta 1 is given by this, tan theta 2 is given by this. Since we are making measurements of theta 1 and theta 2, assume that they are constant. And then from this equation, by rearranging the terms, we get this. So this is easy to solve. We can easily solve for x and y. The next one, the reference is not known. So we assume that the reference makes an angle theta with y. So this is theta. And since we are making measurements with respect to reference, this only we know. Theta 1 and theta 2 only we know. We do not know theta. So what we do is we can write the angle relative to y direction. Then the angle will be theta plus theta 1. So tan theta plus theta 1 is given by this. Then tan theta plus theta 2 again given by this. Okay. So this we can write as A and this we write as B. And then using the third transmitter, we have another equation. So tan theta plus theta 3 is equal to C. Okay. Now what we can do, this we can write theta plus theta 1 is equal to tan inverse A. Theta plus theta 2 is equal to tan inverse B. Then if we subtract this one from this, we basically have theta 1 minus theta 2. And then on the right side, you have tan inverse A minus tan inverse B. And then we can apply the tan inverse formula that will give us tan inverse A minus B by 1 plus AB. Simple trigonometry. And then if we put tan on the left side, you basically have A minus B by 1 plus AB is equal to tan theta 1 minus theta 2. Since we know both theta 1 and theta 2, this we can write as K1. Similarly, for the other pair, theta 1 and theta 3, we have A minus C divided by 1 plus AC is equal to this K2. Now, just need to do some algebraic manipulations. So these are the equations we got. Then rearranging terms, we get this one. Okay, and then next we are going to substitute for A, B, and C. So if you just do substitution, this I have shown the steps for this equation. The same can be done for this one also. So you have this one, and then you just need to rearrange the terms. So x, y, see here x, y we have, and then minus x, y. So x, y actually cancels. We basically have x terms. So here using this upper bracket, I have shown all the x terms. Okay, this one, this one, this one, and then yeah, these three terms. And then similarly we have y terms. So using this under bracket, y terms are shown. This is y, and this also y. And then we have some constant terms. So if you group all the terms and then finally rearrange them, on one side you basically have x squared, then x, y squared, y, and then the constant term. And x and y have the same coefficient, k1. So this can be put in this form. Okay. So this is from the first equation, and then from the second equation we get another one. Now we can easily solve these two equations, but we get two sets of solutions, right? Now only one set will give identical theta. So if you use the x and y that you got, you get two sets of x and y. The correct one, so using this x and y, you can find theta from this equation. The correct x and y will give the same theta. The other one will not give same theta because we have a unique user position here. This is how you can eliminate the wrong set. Yes.
What is theta 3?
Another transmitter. You just have another transmitter, theta 3. You will measure theta 3 just like theta 1 and theta 2. You need 3 transmitters.
Okay.
Have you understood what has to be done? So this way you can do it easily actually. Next, Doppler. So are supposed to show that Ft is equal to minus Ft by c into Vr. Here is the relative velocity along the line of sight. So this is the line along which the relative motion between the transmitter and the user, the receiver, occurs. Now to visualize this, we'll consider a simple case where either the transmitter is moving or the receiver is moving. So we are going to consider two cases separately. Transmitter is moving and then receiver is moving, and the relative velocity is Vr. So first assume that the transmitter is moving towards the user or receiver, or the receiver is moving towards the transmitter. Okay, in this case, the transmitter is moving with the relative velocity of Vr, and in the subsequent derivation, we'll just consider the magnitude of Vr, not any sign. In the second case, we assume that the receiver is moving with the relative velocity Vr towards the transmitter. Again, the magnitude is considered here. Okay. Now here we show one cycle. So this is the starting point of the cycle. This is the end point, a beginning of a cycle and the end of a cycle. And we know that the wavelength is lambda. When Vr is 0, wavelength is always lambda as the wave propagates in space. So our objective here is to find the relative distance between these 2 points A and B as it travels in space, and also the transmitter travels. So transmitter also moves along the direction of propagation of the wave. So the wave also moves in this direction, transmitter also moves in this direction. Okay. Now let's say at t is equal to 0, this is where the transmitter was, and the point A left the transmitter. Okay, then point A keeps moving in space at the speed of light, and let's say after some time t1, it has come here. And the distance between old A and new A, when the point A started from the transmitter and where it is at t is equal to t1, that distance, let's say, is lambda. Okay. Now the transmitter is also moving, correct? So over this time t1, the transmitter has also moved, right? So let's say after t1, this is where the transmitter is. Okay. Now since this point has moved distance lambda, that means after t1, B has to leave the transmitter. So at the new position of the transmitter, B will leave the transmitter, correct? Now in this case, what is happening? So transmitter is stationary. We assume that the receiver is moving towards the transmitter. So let's say at t is equal to 0, point A reached the receiver here. Okay, so it reached the receiver. And this is where B was at t is equal to 0. We know the distance between A and B originally is lambda. Now after t1, the receiver has moved in this direction to this point, and B is also moving. So let's say at this point after t1 they meet. B reaches the receiver at this point. So how much distance has B traveled? From here to here it has traveled ct1, and how much distance has the receiver traveled? From here to here it has traveled Vr into t1, correct? Now we know that the total distance is lambda. So ct1 plus Vrt1 is equal to lambda, right? This is clear? You can visualize what I said. Otherwise, whatever I will show on the next page will not be clear to you.
Yes, ma'am.
Okay. Let me explain this one first. So we know that ct1 plus Vrt1 is equal to lambda, correct? So from this we can find t1, right? So t1 is equal to lambda by Vr plus c. Now the receiver received A at t is equal to 0. And when did the receiver receive B? At t is equal to t1. How much distance has been traveled over this period of time? CT1. To reach the receiver, B has traveled this distance, CT1. So the receiver received A at t is equal to 0. It received B at t is equal to T1, and B has just traveled distance CT1. So as per the receiver, the changed wavelength will be lambda prime is equal to C into T1. And then we substitute for T1, so that will be C into lambda by VR plus C. So this is how the new lambda is related to the actual lambda. We know that F is equal to C by lambda. So from this we can find the relationship between the new F as seen by the receiver, the received frequency, because that will be C by lambda prime. So this is F prime, and then similarly lambda, so it can be related to Ft, the transmitted frequency. And since we are taking reverse, we have F prime is equal to Ft times, this will come on top, we have 1 in plus VR by C. And then Doppler is the difference between the received frequency and the transmitted frequency, so it is equal to Ft into VR by C. Do not bother about the magnitude at this point. And here we see that it is, since we have considered only the magnitude of VR, this is positive. So when the receiver is approaching the transmitter, Doppler is positive. And that is what we are getting from here. How about this one? So in this case, B leaves the transmitter at this point. How much time does A take to come from this position to this position? This distance is lambda, and we know that A travels at the speed of light, right? So it moves distance C. C is the speed of light over a second. How much time will it take to move distance lambda? So that will be lambda by C, and that is only equal to T1, right? Because we know over T1 it has moved distance lambda. So lambda is, T1 is equal to lambda by C. How much distance has the transmitter moved over this time? That is VR into T1, right? So VR into T1 is basically VR by C into lambda. So what is the new distance between A and B? A and B is basically lambda minus this distance. So lambda minus VR into T1. And then if we substitute for VR into T1, we basically have lambda is equal to 1 minus VR by C. And then following the same method as in this case, we get Ft is by, so this C is a typo actually. This C will not come, okay? This C here and this C will not come. So F prime is equal to Ft into 1 plus VR by C. And then again by taking the difference, we get the Doppler. At this point again we have considered only the magnitude, and we have assumed that both the transmitter and the receiver they are moving towards each other. So basically this, in this case the transmitter we assume is moving, here we assume the receiver is moving, but they are moving towards each other. How about the case when they are moving away from each other? So using the same method you will find that this becomes negative and this becomes positive. So when the transmitter is moving away, instead of it being here, it will be on the other side. So you, to get the distance between A and B, you have to actually add these two terms. Similarly, here you need to subtract. Okay, and if you follow the same method, you will find that you get a negative sign. Fd is equal to this one. We know that for the case when the transmitter and receiver is moving away, the Doppler is negative. Now let's consider the actual case. So this is the receiver, this is the transmitter, and this is the line of sight, and the R is the distance, instantaneous distance between the receiver and the transmitter. So when the transmitter or the receiver, they move towards each other, then R actually reduces, right? Because they are moving towards each other, so R reduces. That means R dot is negative. When they move away from each other, then R dot is positive, right? So R dot is actually VR, right? R dot is nothing but VR. So if we incorporate the sign of VR in 1 and 2, So in this case, it is actually an approaching transmitter or receiver, which means VR is actually negative. In this case, VR is positive. So combining them, we can write this is the Doppler. So when VR is negative, this is negative, negative, positive, and we get this one, positive. When VR is positive, that means they are moving away from each other, then automatically this is negative. So this equation shows both the cases. So FD is equal to minus FT by C into VR when VR also includes the sign. When they are moving towards each other, VR is negative. When they are moving away from each other, VR is positive. So if you also incorporate the sign of VR, basically if you write R dot itself is negative when they are moving towards each other, and that negative will be positive. And in the other case, you have positive R dot and Doppler is negative. That's it. If you have any question, you can quickly ask me tomorrow. And those who have been asked to email their answers with clear explanations should do so. And do not scribble something here and there and show me your solution. This way I will not see it next time. So tomorrow also you are supposed to explain to me some more problems. And whatever we are discussing regarding the homework is included in the Excel. So in the email, all of you got my email? So yesterday I had sent an email to all of you. Have you got?
Yes, ma'am.
So there I noted some change of dates. So note them down clearly and do not follow the old dates. Okay? There will be 3 exams. The first exam will be this Friday, and then the second one will be on 25th February, and the third one will be in April. And the project presentation will be in March. As per that email, syllabus for the exam is up to today's class. But tomorrow also we are going to discuss some more homework problems, and those homework problems are included because they are based on the portions that we already covered. Okay, so don't think that whatever we are going to discuss tomorrow is not included. They are included. And since we have half an hour extra class tomorrow, if we get time and discuss some more theoretical concepts, those things are not included in the exam. But whatever we discuss regarding the homework problem are included in the exam. Okay, that's it.
Ma'am, that CD, how CD equal to RE, can
We
you?
discuss tomorrow,
Tomorrow.
no, I actually want you to think. So I have.
We tried it, ma'am, but still not able to.
1 minute, let me complete. This is important. V is equal to omega cross R. So whatever I discussed in this regard, you just think about that, and whether using that you can explain that this distance is R. It is possible, and it is very simple.
Okay, ma'am, we'll try.
Okay, that's it. You can leave now.
Thank you, ma'am.